All right, today's lesson is on C fundamentals. These are a few concepts that we need to learn before we start programming. We'll go ahead then and go through a section on comments, keywords, identifiers, data types, variables, constants, what ASCII is, and what tokens are. Start with comments. Comments are used in your programs to make things more human readable. We document what we're trying to do in a program. It makes sense for us as programmers later when we come back and look at our program. If we have comments in there, it makes it easier to remember what we were doing. We'll find that there are two different ways to create comments. We can do a /*, no space in between. That will start the beginning of a comment, and the comment will not end until it encounters the */. So you can put all of that on one line, or you can have multiple lines with that. We'll show some examples of that in just a minute. All right. The other way we can do a C-style comment is 2 // no space in between. Everything after the 2 / until the end of a line will be considered a comment. We'll see that comments are ignored by the compiler. But when the compiler goes through and checks the syntax of our source code, it will completely ignore our comments. They won't be in our object file or our executable instructions. Like I said, they exist so we can understand the programmer's intent. It makes things easier to maintain later. And it also makes code easier to understand in terms of helping one another. If you're students and you need to look at somebody else's code, or your instructor needs to look at your code, having comments in there saying what you're trying to do will help you, help anyone help you, as well as we're going to develop all of our programs after we develop algorithms. So remember, we said in our previous Hello World lecture, we mentioned what an algorithm was, that it's a series of steps that we're going to follow to solve our problem. But we'll want to put all those algorithm steps in comments. Right. Now, technically, according to the C standard, the compiler just takes your comments and replaces any comments with a single space in your code. And the spaces are called white spaces, and the compiler tends to ignore white space. Okay, if we go back and look at our Hello World program from last time, and we add a lot of comments to it, to remind ourselves what each part of the program is. But we said then that this pound includes standard io.h, that the pound sign is a preprocessor directive. Include means to go out and find the header file. So the header file standard io.h, it will go out and look for this, and the preprocessor will bring the code from this particular file and add it to your source code. Right. So here is a set of comments. 2 // together. Everything from here to the right is considered a comment by the compiler. And that's where we wrote preprocessor directive to remind us what it is. Right. On the next line then, 2 //. Everything to the right here is a comment. And notice here in this slide, I've had all the comments turned to green to make them stand out, to be easier to read separately from the code. All right, last time we also talked about a function header. We said that every C program has to have a main function in it. And program execution always starts from main. We said the form of our function then, here's the name, main, right? It has to be spelled exactly like this. It returns, it has a return data type. So here's our return data type, that's integer. And then it has a parameter list that starts with a left parenthesis and ends with a right parenthesis. Inside, we have this keyword void. Keyword is a reserved word of the language. Void means we're not going to pass any information to our main function. Later when we study functions, we'll learn that we can pass information to a function through this parameter list. All right, next line, left curly brace. We said that a left curly brace starts a section of code. And here, this left curly brace starts main. Right, this is the beginning of the main function. So we've got a comment here to remind us that the start of a function body is indicated by the symbol. On the next two lines, to give an example of a multi-line comment, we have a / together, right? No space in between. Everything after this is considered a comment. This next line is considered a comment, and here I chose to end it here with a asterisk / So that's the end of our comment. Right. And this says we're calling a function named printf. Here, when we have the word printf, that means we're calling the function by name. This is the name of the function printf that's defined in the header library standard io.h. And remember last time then we just had this message hello world print on the screen. Right. The last thing our program does is we return 0 back to the operating system. And we said that we return 0. 0 is customary when a function ends normally. And we have the return statement here because when we defined our function main, we said the return data type was an int. So we actually have to have a statement with a keyword return. And then we actually have to return some sort of integer value. And that's what this comment reminds us of. And finally, the end of our function body is indicated by this right curly brace symbol. Well, there's a lot of comments in hello world. Typically, we wouldn't comment hello world that heavily, but this gives you an idea of how to use comments and remind you what each thing in this program is doing. Okay, let's move on to keywords then. Keywords are reserved words of the language. You can't redefine them, meaning you will not be able to use them in identifier names and function names. Right. They have a very specific meaning that we'll learn throughout the course of these lessons. Below is a table that reflects keywords from C99. Well, there are different standards for the C language. There was a 1989 standard. There was a 1999 standard. There was a 2011 standard. One of the nice things about C is it's a language that has very few keywords. As of 1999, it only had about 32 keywords in the language. As of 2011, a few more keywords were added to the language. In relation to concurrent programming, we won't be getting into concurrent programming, so I haven't included those here. But as we go through these lessons, we will eventually end up learning all of these keywords. So don't worry about memorizing them all right now. What I suggest is when we learn a new keyword, go ahead and write that down and keep a list of the keywords that you've learned so far. Right. A complete list is found here, so if you want to see the ones that were added by the 2011 standard, this is a really good reference to find this. Right. Next, identifiers. So identifiers are going to be names for variables, functions, macros, structures, unions, and other entities that we'll learn to write. Initially, we're going to be concerned about naming variables. So let's go ahead and take a look at the identifier naming rules. These are very important for you to learn. That will make your coding faster in the beginning. I don't always ask you to memorize very much, but I would memorize these 4 rules. The sooner you memorize them, as you write programs, you won't have to look them up again. It will save you time. Now, rule number 1. An identifier must begin with a letter of the alphabet. Anywhere A through Z, so small case, or uppercase A through Z. Or it may start with an underscore character. So the start of the name can start with a letter of the alphabet or the underscore character. After that, then rule number 2, the identifier name may contain letters, can contain the digits 0 through 9 and underscores. No other special character. So the only special character we'll ever have in a name that is not alphabetic or numeric is the underscore. Rule 3, C is case sensitive, distinguishing between uppercase and lowercase letters and identifiers. But here's an example down below. These are all different identifiers. There's 8 different spellings of the word cat. So all lowercase, 2 lowercase letters, and an uppercase letter. The compiler would consider each one of these to be a completely different identifier name. And we tend not to use these same names. We wouldn't use all 8 of these in a program. It would be confusing for us as humans reading it to keep track of what each of these meant separately. Right. So be aware of the fact that C is case sensitive. Finally, the last rule, number 4, keywords may not be used for identifier names. Right, so as we learn the keywords, we said these are reserved and have special meaning in the language, so you can't use them for an identifier name or you'd be redefining their meaning. Naming style conventions. All right, Programmers follow conventions, right? It makes it easier when you're reading other code, when people are reading your code. So normally, we use lowercase letters when we create variable names, all right, so identifier names. So here, an identifier name, account, size, or height. These commas are simply to separate the list. They aren't part of the identifier names. Notice I've used all lowercase, and that works really well when you just have one word. But we always want our identifier names to be meaningful. So eventually, we'll come up with longer names. And there's two different conventions when we do that. The first convention is that we use underscores to separate words. So in this identifier name, line count, we used an underscore to separate these two words to make it easier to read. If we were to run this all together, it would be difficult to read. Array size, box height. So you can see the convention. Otherwise, if you don't want to follow this convention with the underscores, the other thing that you will see is that the first letter of the second word is capitalized, and that makes it easier to read as well. Notice line count, it's very easy to see right here that this is a new word. Array size, box height, those are easy to read. So you pick your own style, convention, and follow it. When you go to work for someone, they will have their own convention, and you will need to follow that if you're writing code for them. Right. The other convention is that we usually don't start an identifier name with an underscore because there are several compiler-defined identifiers in the standard C library that already start with an underscore. And we actually don't want to accidentally create an identifier with the same name because duplicate names can cause definition conflicts. So normally, don't start your identifiers with an underscore. As I just said earlier, identifier names should be descriptive. When you look at them, you want to make sure you know exactly what they mean. So in this example then, if we were to create some identifier names to calculate the sum of grades, right, for different assignments in a class, I'm asking you here, which do you think are easier to understand? So if we had A, B, C, and D, and each one of these was supposed to represent then the total that a person received on the assignment. Or if we name these identifiers instead of A, B, C, and D, what if we named it the sum of homework 1, the sum of homework 2, the sum of exam 1, and the sum of exam 2? It's much clearer from their names what information these identifiers hold. Now, if your program's relatively short, it might be easy to remember what A, B, C, and D are. But if anyone else comes to look at your program and try to look at A, B, C, and D, especially if you don't have any comments in there, it becomes very difficult to understand what you mean by that. So use descriptive identifier names. You will be graded on that in this class as well. Always use descriptive names. All right. Let's go ahead then and look at which of these are legal and which aren't. And in the upper part here, the word average is legal name. There's nothing in the C word that reserves the word average, so we can use that. Also as well, underscore 2 cats is legal. You may start it with an underscore. We said by convention we normally don't do that. You may have a number anywhere in the identifier name except for the beginning, so this is legal. Pi is another legal one. We don't have a constant defined by the C language, pi, so you can use that as an identifier name. You can have your identifier names be very short, so just the letter J is also legal. Here we have some examples then of illegal. 2 cats. Why do you think this one is illegal here? Well, we just said that we can't start an identifier name with a number, right? Remember, we can only start it with letters of the alphabet or an underscore. Right, let's look at this one. Underscore, dogs rule, underscore, cats rule, exclamation mark. The exclamation mark in this one makes it illegal because the only special character that we can have is the underscore. And finally, the last one, double. Well, we haven't seen double yet, but double is a reserved word of the language. We can't use that as an identifier name. And there's really no limit to how long you make your identifier names, but you want to remember, depending on the compiler you're using, sometimes it will only look at the first 31 characters. So if you have names that are very similar in the first 31 characters, you want to look up and learn something about your compiler to see what it recognizes. let's start talking about data types now. We want to think about how information is stored and represented in the computer program. Right. So we're going to talk about integer families, floating point families, and avoid data type. Right. As I just said, the data type specifies what kind of data it will hold. Right. Everything in a computer is stored in binary. Everything in the digital hardware system is stored in binary. But it all depends on how our program interprets it. It may just be a series of ones and zeros that are stored, but the data type will tell our program how to interpret those ones and zeros. It gives it meaning. Right. All right, so two families of data types, integer and floating point. So integer data types store whole numbers only, 0, 1, 2. They don't have any fractional part, so that means no decimal point. They may be signed or unsigned. They can be positive, they can be negative. So signed numbers can both be positive and negative. They can have a 0. Unsigned numbers will always be positive, and they can also represent a 0. Floating point types, then, are numbers that can have digits after the decimal point. So they will have a decimal point in them. They're signed, and that they can store both positive and negative numbers. Right, just a reminder of what an integer is. Right, numbers with no fractional part. And here's an example of a number line. Integers can be much greater than -10 or +10. This is just simply an example to remind you of what an integer is. The range of values of a type depends on the number of bits used to represent that type. So bits are binary digits. Depending on how many we have, we can store the smallest to the largest number. We'll talk about those ranges in just a minute. Floating point numbers. So there is no fixed number of digits before or after the decimal point, and the decimal point can float, right? Floating point numbers, positive or negative, they can be signed, and here's some examples. So you can see here we could have a number 0 point, we could have 9 digits, 12 digits, we can have as many digits as we want before and after this decimal point. Right. In this case, 12.34567889, we have 2 digits before, 7 digits after. Here's an example, 0.0. We can have just 1 digit after the decimal point. Right? We can have a negative number, -19.75. So you can see in all these different examples, the decimal point is floating around. There's nothing that says you can only have so many digits to the left and so many digits to the right, and that's why we say it floats and it is not fixed. So let's look at some basic C data types that are defined by the language. Types that we will commonly use is for integer, right? This is an integer type in that it can store whole numbers only. The minimum size by the standard depends on your processor register size. Now, on a general purpose computer, the standard says that the minimum size is 32 bits. Short is another data type. It's in the integer family. It only holds whole numbers, but it only has 16 bits of storage, right? It has less storage than an int. A char typically will store character information in there. It is an integer value. So it stores whole numbers only. It's part of this integer family. It only uses 8 bits for storage. Float and double are both of the family floating point. Float uses 32 bits, double uses 64 bits. So you can store larger numbers in a double than you can in a float. Right. All of these types, so float, double, short, and int, these are all signed by default. We'll talk about the keyword signed and unsigned, but if we just write them like this, float, double, short, or int, these are all signed, meaning you can store a positive number in there, a negative number in there, or you can store 0 in there as well. So signed integer types. The keyword signed, so signed short, signed int, signed long, that is very clear to the reader that you mean for this to be a signed number that can store both positive and negative numbers. You won't see the keyword signed written very often. You'll just see the word short, the word int, or the word long typically written. You'll rarely ever see signed. Know that these are both the same thing. So long is also another data type in the family. it's usually 64 bits long. So it's a little bigger than an int, depending on your processor. It will actually always be longer than an int. All right. Notice what I should have mentioned in the previous slide. I didn't mean to go to the end. Scroll back down. Here. So what I should have mentioned here, see everything in blue, int, short, char, float, and double, these are all keywords or reserved words of the language. You can't use those as identifier names. They all represent data types. Same way here, then we've added in sign. This is another keyword. Long is another keyword. The one we have to remember is char. Remember, it's part of the integer family. A char can be signed or unsigned, but the C standard isn't clear. C standard left it up to the compiler implementation. So if you really want to be clear about it, if you were to just write char, you have to know what your compiler, how your compiler treats it. Is it treating it as signed or unsigned? So if you want to make it really clear as to whether or not this is a signed or unsigned number, put the keyword signed in front of char. And that way you can represent both positive and negative numbers in it. Unsigned. So in order then to guarantee, since the others by default are signed, we have to put the keyword unsigned in front of the data type declaration. So now then we have an unsigned char, an unsigned short, an unsigned int, and unsigned long. These are all part of the integer family. We just use different number of bits to store them. 8 for a char, 16 for a short, minimum of 32 for an int, 64 for a long. So use that keyword unsigned. So now we've seen quite a few keywords already. Right, now to talk about then the range of numbers that we can store in them. Let's look at char. Char, we said, is 8 bits, 8 binary digits. There are 8 bits in a byte, so it occupies 1 byte of memory. An unsigned number you can represent anywhere between, and these are base 10 numbers, decimal numbers, 0 to 255, unsigned. Remember then that 255 is 2 to the 8th, so 8 bits. Binary can have 2 states. So 2 to the 8th minus 1, we lose 1 for 0. So there, your range of unsigned numbers in an 8-bit number is 0 to 255. Your range of signed numbers in an 8-bit number is minus 128 to plus 127. Or here's the formula, minus 2 to the 7th to 2 to the 7th minus 1. We have this range of numbers because one of the bits in our 8 bits is used for the sign bit, only leaving us 2 to the 7th combinations for magnitude. Right? 0 is represented as well. Typically, you'll see that everything in C is stored as in a 2's complement form. So if you're unfamiliar with 2's complement, we'll talk about binary numbers and 2's complement in a separate lesson, but that is where this information comes from. Now with a short, you can see that 16 bits, 2 bytes, 8 bits in a byte, so 16 divided by 8 gives us 2 bytes. We can store an unsigned range of numbers of 0 to 65, 535, or 0 to 2 to the 16th minus 1, and a signed range here of minus 32, 768 to positive 32, 767. Right? And you can see these other ranges as well. This is not something I would expect you to memorize. No, so don't sit and try to memorize all these ranges and all these bit sizes at this point. Typically, these are things you'll look up. Let's look at floating point types then. We actually have 3 floating point types. We use that when we need to represent a real number or a number that has some information to the right of the decimal point. A float occupies 32 bits, which is 4 bytes. And it can store a very wide range of values because of the way the decimal point can float in there. In another tutorial, we'll talk about how floating point numbers are stored in binary. Right? It's precise to 6 decimal places. So what you want to know in terms of these is not only the range of numbers, but the number of decimal places that it can store. Right? So a double is twice as big as a float, 8 bytes, and a long double is 10 bytes. So you can get even more decimal places, greater precision if you need that, but it will require more storage. So typically we'll work with float and double. We don't always work with long double because we don't always have numbers that are that large. Okay, our final data type. So we had talked about the family of floats and the family of integers. There is a void type. So it holds no value. Its size in bytes is 0, meaning if you declare something as void, it does not occupy any memory. So that's why we say its size in bytes is 0, and we can't store anything in it if it doesn't occupy any memory. It's primarily used to specify the return type of a function when the function returns no value. We'll learn about functions later. What we've seen already is that it's used to specify the type of a parameter. So when no parameter is passed to a function, we put void in here. And that's what we'll see it used for until we learn to write functions. Right? So just remember that void does not occupy any memory, and you can't store anything in it. Now later, and much later in another lesson when we learn about pointers, we'll learn that there is something that's a void star pointer, and it will create some memory to store an address, but you don't need to remember this right now. We will come back to this much later. Right. So when we declare variables, when we learn to do that, we're not going to declare one of type void. The compiler will issue an error with that. All right. So here, just to reiterate that it's illegal to declare a variable of type void. If you were to do this, if you were to say data type void, and here's your identifier name A, if this is a C statement, so C statements end with a semicolon, I've got a comment out here that this is illegal. The compiler will not be happy about that. Once again, remember it holds no value and occupies 0 bytes in memory. Later you will see things called void stars that are void pointers. We don't have to worry about those right now. All right.